So, you finally dedicated the appropriate time to develop your coding skills. Weeks of hard work go by. You type in your new code. It actually compiles error free. You go back to the game engine. You hit play and nothing. Welcome to Mud on a Monday, a series highlighting the setbacks along the path to success of individuals who are prominent in their craft. From politicians, business tycoons, and technological visionaries to legends of sports, music, film, TV, and of course, video games. Today's episode is on the creatively brilliant Ada Lovelace. They say programming teaches you how to think in a different way. So let's go back towards the origins of that thinking. The transition from calculation to computation really gains traction right around this time. So there was a lot of controversy that I found while I was researching Ada Lovelace, which I should probably say I did not know much about. So it was actually pretty cool to find all of this out. Pretty damn cool, in fact. So there's a lot of controversy over the claims whether she really is the first programmer, and well, that's a rabbit hole I don't really care to discuss here, but you can Google it. It's pretty interesting, I suppose. But so there's enough evidence to show there was programs before Ada's. However, nobody had ever written one as complex as hers. So specifically the inclusion of looping and numerical constants. So those are crucial fundamentals of modern programming languages. Those were not features found in the programs written before Ada's. So her understanding of these concepts was also leaps and bounds ahead in understanding the machine that Charles Babbage had built. We'll talk about him shortly. So I don't really want to get into the controversy. I'll just leave that to the scholars. So I'm much more interested in how Ada's mind was able to see something that no one else did. I mean, she was in contact, and so was Charles Babbage, with some of the brightest thinkers of that time. This episode will be much more game development heavy, since I wanted to dig a bit into game dev history, and well, naturally Ada's name popped up, right? So since I didn't really know much about Ada Lovelace besides the basics on Wikipedia, I decided to do some research and ended up getting really excited, and decided episode 3 would be on the Enchantress of Number, as Charles Babbage called her. Charles Babbage is a Cambridge graduate, friends with Michael Faraday, John Herschel, and other genius people of that era, many of whom I'd never heard about either. So Charles Babbage was known as a polymath. He was a mathematician, he was a philosopher, inventor, mechanical engineer, and because he makes things, he was also a marketer. He tried to sell these things, he tried to drum up buzz. So he starts out by inventing the difference engine. And so this was basically a mechanical calculator that could tabulate polynomial functions. This machine was huge, though. Big machine. So human calculators made errors. That frustrated Babbage. So in order to produce more error-free calculations of polynomials, he invented the difference engine. It used a mathematical method of divided differences to be able to solve these equations. Now, at the time, it was a machine that would have been of tremendous use to scientists, engineers, navigators, and mathematicians by letting the machine do most of the calculations while they just focused on the more abstract thinking of their respective field. So polynomials could closely enough approximate most mathematical functions. So that's why it was so useful to them. So Ada Lovelace was around 17 when she met Babbage in 1833, and he's lecturing on the difference engine at this time. She was a frequent spectator of his and eventually befriended him. So Babbage soon loses interest in the difference engine. For all its glory, the difference engine had some issues. So being only able to handle polynomials of 31-digit numbers and up to the seventh order of differences was the least of its problems, okay? Its problems could be understood in layman's terms. No kind of arithmetic knowledge or background was necessary. So it was really difficult and very expensive to build. This was a machine that required highly precise parts, and it was tough to find people to work with. And he did have a falling out with the person that he worked with, who at the time was known as the number one engineer to make such parts. So it doesn't work out. The difference engine, while a success, was very flawed. So additionally, the flaw in its actual function was the fact that it couldn't be modified once it was running. So that doesn't seem like such a big deal. But these numbers were punched in manually. So imagine having to punch in some equation, waiting for that thing to process that, and at some point in the middle deciding, oh, I want to change that. You'd have to stop that, reset the machine, repunch everything, and do it again. What if you have another change? You got to do that again. So it made it incredibly annoying to try to do that. So Babbage eventually comes up with a much simpler design and a completely different engine altogether. So he calls this the Analytical engine. And this was the absolute gem of his contributions. Now, it was never built. It was only ever designed very, very meticulously and well detailed, but never built. And this was due to his inability to secure sufficient funding for it. This was much more of a general purpose machine as opposed to the difference engine's very specific purpose and method of calculation. The Analytical engine was simpler in design, but it was way bigger. It was huge. It was so big that it would require steam power. The parts would be quite recognizable to us today. Nearly 100 years before the first computer is built, Babbage's design is very modern for a computer. It's got a CPU, it's got memory, it's got power, it's got a way to program it. The information was input via a set of 3 punch cards. The first was to set the mathematical operations that were going to be used. The second was for numerical constants. And the third was for the loading, storing, and transferring that would go on. So it's very easy to see the similarities already between these 3 punch cards in modern programming structure today. So the engine's programming languages worked like modern assembly languages, in that they were capable of loops and conditional branching. Now, I've been doing game development for about a year. I've grown to love going over Unity C# scripts. It's a great way to learn more about programming, but I just find it pretty neat how different programmers do the same thing in different ways. Pretty damn cool. Some are more accurate methods of doing that than others. Say, how you decide to do your player controller, right? Some programmers are much more accurate about it. Maybe the game calls for it. Maybe the game doesn't need it. But it's pretty neat to me the different types of coding that we'll see for the very same purpose. Pretty damn cool. So loops and conditional branching are all over, right? I mean, every programmer knows there's great power in an if-else. And, in Unity, coroutines are awesome. When you finally understand a for loop, it's like, man, it's exciting, right? So it's pretty cool to see that even back then, in the first design of a computer, we already see those fundamentals there. It's essential to the thing, right? So Babbage himself wrote about 20 plus programs for the analytical engine as he attempted to secure funding for it. The British government loved the machine, but did not remotely like the idea of giving Babbage the funds he needed to build it, especially after he had lost interest in building the difference engine so quickly. It wasn't something that was easily understood, so it's not like they figured, this is gonna be the end. This thing will only get better with more funding. You're gonna stay focused on this. They didn't really know that. Now we get to the part where we really discuss some of the things that I found that, like, man, there's something to learn there. I thought it was pretty cool. So, teamwork and creative thinking. Oftentimes in game development, many of us work alone. When you're just working by yourself, right? Sometimes it can get very stagnant. The creativity, the flow of things. That's what I want to discuss here. Babbage is, by all accounts, a genius. Incredibly smart. To have invented a machine like this, incredible. Nevertheless, Ada was able to see something that he completely failed to see because it was something that, frankly, he wasn't interested in. So this is where having other type of thinking, other methods of approaching a problem really help. So Babbage was invited to Turin, Italy to give a lecture on his analytical engine in an attempt to secure funding for it. So an article describing the engine was published by mathematician Luigi Federico Menebrea. So he would actually go on to become a military general and prime minister of Italy. But at this time he was a mathematician and the article was written in French. Charles Wheatstone, a friend of Ada, asked her to translate the article, and Babbage himself suggested that she add her own appendices. So Lovelace spent about 9 months working on it and had input from Babbage along the way. She called these notes A through G. Ada was able to go into much more thorough descriptions of the machine's potential than Menebrea was. The article was 1/3 the size of her notes. These went from stating the differences between Babbage's difference engine and the analytical engine to showing an example of how you could program it in a manner that showed off the machine's capabilities. That was the goal there. So Note A really sets the tone for the future of computer science. I mean, essentially, Ada states that the attributes of objects that could be represented by math and which could be changed could also be programmed in addition to simply using the machine for purely mathematical calculations. That's all Babbage saw. That's all he was interested in. And so was Menebrea. There was no other insight towards this machine serving a greater purpose. So Ada immediately saw that these numbers, while it's calculating and it's doing its own calculations, those numbers could actually represent something besides just a number. They could be a way to store data. We do that now with that. That's fundamental from just calculating numbers to now computation. how you use that data to make a software program, a cool little app, a game, a navigation system, all sorts of things. Ada creates the most exquisite program of her time by calculating Bernoulli numbers. So, unlike those of her time, her program shows off the capabilities of the analytical engine by using looping and numerical constants, something that was not found in Menabrea's article. He showed some examples as well, and Babbage had as well, but not to this extent. It's not hard to think that with Babbage's input, she could gain much better insight than most by appreciating the technical details. This could allow her to think of potential that perhaps Babbage didn't think of that could increase the likelihood of funding. Who knows? So that's just my thoughts. I didn't really find any evidence of that anywhere. I just know that he was desperate for funding, and these are friends. I mean, I would help my friend out if there's something that I don't think most people would understand, just because, hey, we're all a little nuts here. I mean, these people are all kind of crazy. They're building machines to solve equations. Mathematicians are pretty nutty people, you know. They want to mess with numbers. That's what they want to do. Those people are just different. It's not conventional, especially not today. Most people hate math. It's fun to say, I hate math. You know what I mean? So these are very unique people. So I would assume it would be nice if you could explain some kind of device that you're making in a way that has much more commercial appeal so that it can actually get built, right? Collaboration lets others see what you may not. There's really nothing like taking an idea that you've created and giving it to someone else and seeing what they do with it, what they add to it, what they replace in it, because it expands it every single time. An idea gets better when you allow another brain to come into contact with it, because no two brains function the same. So no two people will see the same things. So you can expose yourself to different perspectives, kind of like going from, knowing one side of a coin to now two, but now this coin has multiple sides. You know what I mean? You can get all sorts of perspective and insights that you maybe hadn't even thought of because you're too focused on building this thing and building it right. And that's what Babbage was doing, all to serve the purpose of going from error-free calculating to now taking that calculation and storing it, doing something else with it, being able to loop and change. That's pretty damn cool. That's already going into a whole nother era now. This is much more than just a mechanical calculator. This is doing computational work. That must have been insanely crazy to think about at that time. Ada was able to see something that Babbage and Menabrea failed to see. Imagine if that isn't there. Maybe we hear about someone else's name and they write something instead of Ada, and maybe someone else takes that slot, I guess, maybe. But it's pretty neat that she's able to instantly see something that they didn't care about. They didn't think of, what are the other purposes that this could serve? But when you're trying to get funding, that would be a pretty damn good thing to think about. What else can I do with this? Okay, so now I have this thing. It did this. After spending so much time working on it, getting it right, why not, right? Why not see what else it can do? What else can I solve with this? So That's where that creative thinking helps. And it helps not to just be thinking alone. So coding might be a technical skill, but any programmer knows that there's a great deal of creativity in programming. It's why we can look at some code and be more impressed by how something is done than what it actually does. So I thought that was all pretty cool. That's pretty much the end of the episode here. I just wanted to pretty much talk a little bit of game dev now. I thought it was really neat that Ada is able to bring a sort of big picture view to Babbage's engine, the analytical engine, almost 100 years before its time. The British government, it seems it would have been insanely expensive, first off. And who knows if Babbage is ever able to actually build it and stick with it. But, man, pretty damn cool to off of designs. Ada had a love for creativity and music, but she had a fascination with math too. So that already brings a very, very unique type of personality and mindset into Babbage's, work. So I think it's really cool to always be able to, keep the big picture in mind. And, sometimes when we finally learn how to do something, we can get so caught up learning this, learning that, especially when you're just starting out. It feels like you're trying to learn this, you're trying to do that. I feel like that every day. And so one thing that has definitely helped is to just see the big picture of what you're learning. In other words, okay, so I learned how to do this with this. What else can I use this for now? You've put in, again, all of this time, all of this effort to learn this, to be able now to then apply it for your own use and to tweak it as you go. The least you could do is see what else you could do with it. I mean, one of the coolest things that I have had happen to me in my very young game development is finally learning how to use coroutines. It was such a revelation. It was one of those moments where I was like, oh man, I really need this. It'd be so cool if I could, add this in. It's not that hard. Oh, I could probably do that with a coroutine. Yeah. So it can be overwhelming sometimes. You're looking at all these tutorials, but take a step back, pat yourself on the back first of all for all the progress that you've made, no matter how slow that progress may go. I thought I'd be a lot further by now, but it just doesn't shake out that way. Just, keep giving it your best shot every day that you can and just go from there. You know what I mean? Inevitably, you will arrive. So, you try to take all those tutorials and see what else you could do. Like, okay, so you learned how to make your own player, complete with animation and a player controller code. Okay, so if you've never drawn before and you went ahead and let's say you grab some sprite sheet off the internet and you just essentially put clothes and, facial hair and now you got your own character. Okay, why not start pixel art? Start there. You already spent all this time doing that, finding some program to alter those sprites. You might as well take the next leap and just keep messing around with pixel art. See where that takes you. You never know. Let's say you make a player controller script and the way that it's written, you're able to tell when you're facing right or left or up or down if you're in a top down or left right if you're in a side scroller. And if you have that kind of code to be able to control how the character moves, not that hard to add a dash to that. It's very hard to add it without knowing what direction you're facing. Otherwise, you're just dashing in who knows what direction. You know what I'm saying? So it's always good to see what else you can use what you've learned for, because you know a lot more than you think. You've been messing with this tutorial, now you're on this tutorial, and you learned this one. You've used this one quite a few times already, so you're not able to, be glued to your notes anymore like you used to be. You're more just fluid with it. See what else you can do with that. You'll be surprised at the results. That's all I'm going to say. You'll be surprised at the results. And maybe some of you listening to this have a lot more experience. I'd love to hear your experiences on that, because at the end of the day, that's what this is. We all have different thinking, and it's good to share your ideas, because you don't know where those ideas will take you and the work itself. And depending on how insane all of you are and all those ideas are together, where the industry may go as a whole, as we found out here in this episode. So, the next episode will come out in 2 weeks. I'm not really too sure. I don't really have any idea who it will be on, as usual. I usually kind of take a few days off, and then I kind of, I don't know, something usually hits it, and I'll go, oh, it would be good. I should, So with a lot of game development going on in the last couple weeks for me, I was like, a cool episode would be on another game developer icon. So in this case, I chose Ada because of what creative thinking and allowing your ideas to be shared can do. And helping your friends, working together. Everything is better when you're doing it together. And in game development, with so many hats to be worn and so much to get done, even for the simplest game, it's so much better to work on a team. So shout out to everyone at Stolen Quarter. Have a good one. Thank you for listening.